In this video, I'm going to show you how to solve log equations, and there are basically two types, and we'll look at the first type. So this one says mix of log and non-log terms, and what that means is that on the left side of the equation you've got an expression with a log. It's log base 4 of 2x minus 4 is equal to, but then on the right hand side this is a non-log term. It doesn't have a log in front of it. So we'll have to use the conversion between exponent form and log form. And that conversion pair is y is equal to log base b of x is equivalent to b the base raised to the y power is equal to x. And what that means is that wherever we see the base in the log, it will serve now as the base of the exponent equation. So in this log equation we see a base of 4, and that will serve as our base in our exponent equation. The y is what's on the opposite side of the log, and that is the power. So on the opposite side of the log is the 2, and that is our power. And that's equal to what's on the inside of the log, in this case 2x minus 4. And now what we're going to do is just simplify this, so we get 16 is equal to 2x minus 4. And then adding 4 to both sides, we get 20 is equal to 2x, and therefore x is equal to 10. That feels really good, but before we accept that as a final solution, we always have to check our potential solutions in the original log equation, because remember, we're not allowed to have the log of either 0 or a negative number. So when we plug that back in, we're going to again check the solution that x is equal to 10. We get log base 4 of 2 times 10 minus 4, and we're going to ask, is that equal to 2? And the answer is, if we simplify this, log base 4 of 20 minus 4 gives us 16 equals 2. And again, if we check that, we get 4 to the second power is equal to 16. And so this checks out, and this is a good solution. Our next example is a similar kind of problem. Again, we have log terms on the left, but on the right we have a term that doesn't have a log in it. So again, we are going to have to use that conversion between log form and exponent form. But before we do that, because there are two log terms, we have to put them together. Remember that whenever you have log terms that are added, when we combine them into one log term, this is counterintuitive, but this is going to be the product of those two interiors. So we're going to multiply log of x minus 15 multiplied by x. Again, that's counterintuitive, but it's based on our property that log of m plus log of n is going to equal log of m times n. So again, in a single log, the interiors are multiplied. Once we've combined the left-hand side over here, we're going to still set this equal to 2. And just like before, we will convert between log form and exponent form. This time it's not intuitively obvious what the base is, but we understand that whenever we have log without a base written, that 10 is the implied base. So I'm actually going to explicitly write that. And now we can do our conversion where we set the base, which is 10, raised to the power, which is 2, is equal to the interior of that log, which is, I'm going to distribute, get x squared minus 15x. Now simplifying, on the left I get 100 is equal to x squared minus 15x. Subtract 100 from both sides. And I can see now, with my minus 100, that this can be factored. And it will have a difference of factors, so I will get one positive, one negative. And testing out factors of 100, we can think perhaps 5 times 20, and the difference of 5 and 20 will give us a negative 15, so we want the larger magnitude to be negative, so we've got a minus 20 over here, and then positive 5 for the other factor. Now, when we get these two factors, we get either x is equal to -5 as a solution, or the other is that it's positive 20 as a solution. And we want to check these. And as you can probably guess, if I let x equal -5, when I go back to the original equation up here, I get log of a -5 minus 15, and I don't even have to go any further, because taking the log of a negative number is going to give us something undefined. So when we checked again x is equal to a -5, this solution will be eliminated. But if we check the other factor, that x is equal to 20, we're going to see then that log of 20 minus 15 is 5, plus log of 20. Is that equal to 2? And if we put the logs together, we get log base 10 of 5 times 20 is going to give us 100 inside. And when we think the power needed to change 10 into 100, so 10 to the second power gives us 100, that does check. And so x is equal to 20 is a good solution.